Okay, everybody, we're going to start back up, and this is going to be a demonstration of what the difference is between C++ and C and what we're going to be doing from this point forward in this class. So for those of you who were here a few minutes ago, before I started the recording, I sort of already had you start doing stuff. If you go into summer 2013 and you click on SEN 909, Object-Oriented Programming with C++, and you go into you have to scroll down to the bottom, past the syllabus, past the lectures and example. You see this section called examples. If you click on it where it says class examples, it opens up this folder here, and you've got 1, 2, 3, 4, 5, 6, 7, 8, 9 files. Click on all 9 files and save them to the desktop or somewhere. I have done that, or I've started doing that, and they're here. I just made a folder, and I'm going to stick them in the folder because I'm going to keep this a couple, until tomorrow, and I don't want to accidentally remove it, and I don't like to clutter my desktop. So I'm moving them all into a folder, and I have also downloaded the assignment number 2 file, so I can show you that one as well. And we may or may not get to that today, depends. But what you're looking at is a complete dev project, dev C++ project. And what you have here is project 1, 909/project1, which is the project file, has a DEV extension on it. The rest of them have a .h file extension on them, or it has a .c++ file extension. So what I'm going to do is demonstrate to you what we're working with now and what the difference is. So what we've been doing all morning and afternoon, or beginning part of the afternoon, is we took and we created one text file. It's called test.c++. We just put everything in it. We had functions in there, we got main in there, and we did everything inside of one program. That's okay if you're writing C programs and we compile and it turns into an .exe file, no problem. But what we really want to do is separate out all the functionality and create a proper format in object orientation to give us a complete object-oriented abstraction of all of these concepts, but put together in more of a module kind of way. So what I'm going to do is demonstrate to you, and then we're going to learn how to build it. So what I'm doing right now is showing you a complete project. This one happens to be on vehicles and cars. So I'm going to double click on the project.dev file. If you have dev installed, this opens up. If not, open up a project in Xcode, DOS console project. Add the documents class not found. Okay, that's okay. Yeah, because they're supposed to be all in one location and they're not. So I can do it this way. If you just had the same problem that I had, you can create a new project. What we're going to do is add all these projects to it, add all the files to it. So you can download them all to the same location, which is what I'm going to do here. I'm just going to take them out of here because I can always download this again. Put them back all on my desktop. And I have to be able to find all these files. When I originally stored them, they were on my desktop, and so they were all in the same file location. I changed the path by putting them into a folder on Windows. So if you have Xcode, you're going to open up a new Xcode project. If you have dev, you're going to put them back out on the desktop. Open up the dev file, or create a brand new project and add the files to it. So this isn't going to work. So I'm going to recreate it, actually. So let's do it this way. Yeah, let's just do it this way. I'm going to create a new folder, and I'm going to call this one class example. Oops. Oh, it is there. I thought I got rid of it. I just moved it over here. It's an empty folder. Okay, so here's what we're going to do. I'm going to go and create a new file in dev, or excuse me, a new project. So we'll just start this from scratch rather than, and then we'll see how this example is going to work. So new project, and this one's going to be a console application, and we're going to go OK. And now I'm going to save it in that folder that I put out there on the desktop. Class example. I'm going to call it project 1, and now it's saved. So now what I'm going to do is get rid of this main because I don't want the main, because it's just going to be a generic. I have a better main that I'm going to use. In fact, I have one of these out here that I downloaded called, do I have a main? I don't know. Let's see. I have some all vehicles or something .c++, but let's just get rid of this one here. So I'm going to remove the main that came with the project. I have a generic project. remove file, save the file, no. Okay, good. Now I'm going to go into project and I'm going to say add to project. And what am I going to add? I'm going to go back out to the desktop and I'm going to select all of these files here. These are all of the files that I downloaded, except for, let's see, C++. And these are good, good, good. Oh, that's because I changed them. I called them 909. Hey, all right. And in the files themselves, they're called something else. They don't have the 909 in front of them. No, they don't. All right, so let's just rename them. Get rid of the 909. I should probably just take out them. Actually, I got a better source for you. I got a better way of doing this, actually. Let's get rid of all these files. I got plan B. Let's get them from a different source. Plan B says go out to this folder here. Where is this folder? This one is going to be right down this URL. This is MCS, which actually stands for Mathematics Computer Science .csueastbay.edu. It's another school that I teach at. I've used these examples all over the place. / and then you have to put this little tilde in there, little tilde sign, B Hacker. So this is my Cal State East Bay account server access. So that one actually works better because I don't have to rename and upload and download and crap like that. So it's actually Unix compiled. So actually this is not a bad source for other examples that are all up here as well. So www.mcs.csueastbay.edu / bhacker. Did everyone get that? Otherwise you have to rename all those other files. Let me know when I can move forward. Not opening up? It should open up. Is it open up now? Yeah, make sure you put the tilde in there. Plus also the server, the ITU server doesn't allow people which is ridiculous, to all go to the same website together. I think there's a problem. Ah, okay, so click on the previous terms link and go into, actually hold on one second. One second, I might have put it in here as well. I did. All right, so click on the one that says 2370, CS 2370. Let me make this a little bit bigger so you can see what I'm talking about. So if you made it to this URL, click on 2370, examples, class example. It's the same set of examples except for that's not renamed 909 this, 909 that. It has the proper names on it. Download these files. So if you click on them, you'll get the same thing as we got before. And just do save. And save them to the desktop. This one will open up just fine because files are named correctly. So go ahead and download this set of files. What I'll probably do in the future is just make a zip file out of it. I might even fix it for this class. We'll see. But what I should do is zip them all together and then just have you download the zip file instead of having you download them all individually like this. But this is a very old example. So, and then I got smart and started zipping things. So as tedious as it sounds, it's worth it. It's worth the investment here. So download all the examples so you have them on your system. Now double click. Does anyone still need the URL?
It's too slow.
What's too slow?
It's not working.
The internet's not working? Is anybody else having problems? Yeah?
No, we need to Create project now and combine these files?
No, you don't. Actually, now all you have to do, if you want, what I can do is zip them all together, upload them to Vhacker, and have you download that in a few minutes. Now when you open it opens up perfectly. So here's what I'm going to do for you. I'm going to zip them all together, put them on Vhacker, have you download that. And then you can open up that and use it. So let me pause this video actually real quick, because you don't need to see that. Okay, so now it's here as a zipped file. So you don't have to download, these are all the separate files individually. I put it here, class example zipped. So when you download the zipped file, save it to your desktop, unzip it. When you unzip, so you don't need to get it from here anymore. Now the files are named correctly. It looks like that. When you unzip it, it looks like that. You got a folder. Open up the folder, double click on project1.dev. And you got that, which is what we wanted. And that's got everything in it. If you're working with Xcode, if you're working with another compiler, you have to add create a new project, DOS console project, add the files to the project. And these files are named correctly, so you don't have to worry about it. So what do we have here, which is an interesting question. Why we're bothering to look at this? We're looking at a certain sequence of classes where this is the finished product. So keep in mind I'm going to run through this in smaller stages, and we're going to create this by scratch. So we're not going to necessarily start at this level. We're going to work in baby steps. But this is what the big picture looks like. A lot of people like to see the big picture so they can see what the smaller, they can understand it better. So we have all vehicles.c++ file. All vehicles.c++ could be called main. Probably should have been called main initially, but it's all vehicles. So if I run it, what I'm going to run, if I compile, I just want to make sure this compiles correctly, and it does. I get project1.exe, which is the name of my project. And if I run it, it's going to give me the output. It's going to look great. And the output that's coming from is coming from all vehicles.c++. So we take main, and we have just regular old integer main, and this is essentially what we've been looking at. If you read through the example, you'll see a bunch of notes on the top. I try to document this as much as possible because it's a nice little teaching example. But this is your typical C++ program. We have IO stream, same thing as we looked at before, but then we have vehicle.h, car.h, and truck.h. What are these .h's? Well, they're the header files, or the .h, which is the specification, and then we have a .c++, which is an implementation that goes along with it. So we take all those function prototypes and all the structures and unions and everything, we stick them in a .h, and then in the .c++ we implement that. So there's two files that go along with each object instead of just one. Everything's broken out into a separate file. As an example, let's take a look at this car concept. So I have car.h, and for the project it's not case sensitive actually, which is interesting because in some compilers, if it is case sensitive, you're going to have compilation problems because this is a capital CAR. So we're including car.h. If I click on car.h, I have something that looks like this. And this has got, you know, again, it's a lot more complicated than what you really need to see right now because it's using inheritance. But it's the implementation, it's the specification of this concept of a car. If we take it down a level, and we're going to build this from scratch in a few minutes, so don't worry about it. If we take it down a level, and we put it down to the base level, or the base class that we've defined, it's really vehicle. Inside a vehicle, we have a class vehicle, and then we're having data members and member functions, and we have everything kind of composed into here, and then we have a vehicle.c++ file. It's not a repeat of the .h, but it's an implementation of the .h. So out here, in this particular land, we've got the file, and we've got this little scope resolution operator that we're using, and we're implementing all of the functionality that we've defined in the specification. So think of it this way: in the .h's, we're specifying what we want, and the .c++'s, we're implementing it. So in Objective-C, it's the same concept. It's the .h, which is the oh my god, interface. They call it an interface. And then we have the implementation, which is the .m file, to remember this correctly. So this is, now they're going to call it a specification. It's not a template. That means something totally different. But you're specifying what you want, and then you have the implementation of it. It's kind of like the concept of a function prototype versus the function implementation that we saw. So if we look at vehicle.h, these are function prototypes, and this is the data. So we have two pieces of data, and then we have two function prototypes that we're going to use. And then in the .c++ file, we're implementing it, which means we're going to write the method bodies, function bodies. And we're going to actually write the code that's going to run. We're going to do this for all of the different classes that we have, and then we're going to have one program that only has main in it. This is main. Only has main in it. And inside of main, we make instances of those objects. And then we take those objects and we, we can exercise the methods on them and initialize the data on them and do a bunch of stuff with them. So don't let this example, intimidate you. Keep it in the back of your mind because you're going to need this example for assignment number 2, and I'm going to revisit it. But I wanted to kind of show you the big picture before I start working with the smaller pieces. This one is a nice one only because it's kind of, well, it shows inheritance as well. But it kind of shows you a nice little layout of how things should be organized. You don't want to stick everything in one file. So let's build something from scratch to sort of see how this is going to work. So I'm going to go File, New, Project, Console Application. And then I'm going to say, I'm going to call this one now, I'm going to call this one Project, what did I call that one I did today? Test? What did I call it? Test. I'm going to call it Test C++. I don't know if I can use the plus plus. Yeah, I can use plus plus in the name. Test C++. But, close project 1 and start a new project. Yes. And I'm going to put this one on my desktop so I can save it and give it to you later. So we're going to do the same thing as I do with the this one here. So this is going to be here. I'm going to put it on the desktop. So now you see I'm back to this old main file. Let's just leave main alone actually right now. So let's see how this kind of works together. So the first thing I'm going to do is I'm going to say, okay, if I'm going to build this project, I'm going to work with C++. Then I'm going to go ahead and start out and I'm going to build a class. So I'm going to build a .h file that goes along with a class. So what I can do then is go File, New, Source Code File, and say add a new source code file to the current project and say yes. So now I have a new source code file. But the new source code file says untitled on it. So I can come over to the right over here. I'm going to call this one, I'm going to rename it, and I'm going to call it with a capital P. I'm going to call it person.h. So, because we're gonna create a person, and then from a person we're gonna create an employee later on, probably not till tomorrow or the next weekend. So we're gonna start out small, and then I know that I'm gonna have another file that's gonna go along with this, and it's gonna be called person.c++. And in person.c++, I'm gonna implement person.h. So at a starting point, this is what I'm trying to do is give you an approach to work with. So you're sitting down, you have a blank screen you're looking at because you're not cutting and pasting and cheating off the internet. In fact, you're going to say, I'm going to write a C++ program. This is how I'm going to do it. So I started a new project. I got person.h because this is the object I'm going to use in the program. So I'm also going to do a person.c++ file. So I'm going to go File, New, Source Code File. I'm going to say, yeah, add it to the project. So now I'm going to go in here and I'm going to rename the file person.c++. And then I have main C++. And it's interesting because you see main is in lowercase. It's just called main because lowercase out here and lowercase main. It's not. It's just it's called the driver program. So in main we're going to make an instance of person, and we're going to essentially be able to run it and do all the things with persons. And I just compiled it to make sure everything worked okay, and it does. So, but we really haven't done anything with person yet. So what I'm going to do in person is define the class that we're going to use. So I'm going to open up and clicking on person.h. And now I'm going to tell you how we're going to write classes. So you don't have to put anything on the top, but you do need the keyword class. So just like we wrote a structure, I'm going to write a class. And in the class, I'm going to put in there the implementation of the prototypes of everything that I want. So at a minimum, you need this. You need class, and it's going to be called person. And then I need an opening and I need a closing bracket. Usually I have something in between, and then I have a semicolon at the end. So it kind of looks like our structure that we wrote earlier. Actually, we wrote one of these. We called it Person B. We've already written a class, actually. So the class is going to have two sections to it. You can put the sections one on top of the other, which is normally people do, and they group things together. Or you can mumble jumble it, make it extremely hard for people to read. Because you have two components to go inside of the class. So every class turns into an object when you make an instance of it. This is why we call it object-oriented programming. We have data members and we have member functions. I like to put the data on the top, because if I put the data on the top, then I can find it easily, and it reminds me of traditional C programming. So I can put up here on the top, I can go, integer age, which is what we did before, and then down on the bottom I can put other things, and I can put functions in here as an example. I can put, what am I going to do? Get age. So let's work with one piece of information. We're going to call it age. So I'm going to try to see if I can document. This is what's called a data member. By default, data members are always private. Because the concept is you create private data members and public member functions. And the public member functions are accessing the private data members. Same thing we did, if this is like the third or fourth time you probably have heard this. It's the same thing we do in Java. It's the same thing we did in Objective-C. It's the same thing you do in C++. It's the same concept. However, some people forget the rules. So you can write the keyword private in there. In Dev, I will tell you, if you start writing it and it's a keyword and it identifies it as a keyword, it puts it in bold. If you accidentally put a capital P in here, it's not bold anymore. No longer a keyword. So we saw some beautiful color coding out in Xcode. In Dev, you get, is it bolder if it's not bold? So I'm going to put a little note in here that says, by default, all data members are private. So we got one of them. Let's just put another one in here. What did we have before? Let's do this at the top. Let's include string. This is where I'm going to get in trouble because I don't know if string is capital over here or not. But I guess I'm going to find out quickly. Well, let's see if this compiles actually. String.
It's lowercase.
Is it lowercase? In Dev? Are you using Dev? No, but see, Dev, I think, makes it uppercase.
Use string.h, that's caps.
That is capped, isn't it?
String.
It was lowercase, though, earlier.
Both are lowercase.
Alright, let's leave it at lowercase and we'll see what happens here. Okay, took it. We're good. Alright, so I included string. You can type this. You guys feel free to type this as I'm going through it, if you can see it on the board here. I put in... I had to include string because I'm going to give a string name. I got a string age. That's good. So I'm going to create what's called setters and getters for this. So we're going to do it manually. There's a ton of tools to do it automatedly. We're trying to learn what these concepts are, so we're going to do it all manually. So on the top, I put by default, all the data members are private, and this is the private. This is data member for age. This is another data member for name. So then now I'm going to put public here. By default, it is public, however. And I've got two sections over here. So in the public area, if I wanted to put another piece of data in here, I can if I want to. So I'm going to just put one here, integer x. I just put something in there just to show you that I can do that. It doesn't really matter. These aren't two mutually exclusive sections where one can only hold data and the other one can only hold member functions. You can put anything you want in there. But what you really want to do here is put in those function prototypes. So remember all the time I spent showing you functions. We wrote like 5 of them or so. And we did the function prototypes. All the function prototypes go in here. So let's put a function prototype in here. And this one's going to be string get name. So string get name. That's just going to return it's going to return a name, but it doesn't take on any parameters. We're not going to deal with constructors yet. And then we're going to have another one. It's going to be called integer get age. That's going to return the age. Those are called setters. Excuse me, getters. We have setters that are going to be used to set the data. So let me put a little space in here. This is my public X, so I can play around with this, you know, out in the main program. So now I'm down here. I'm going to say now we're going to write. I'm going to write a form of setters. So I'm going to say integer set age, and it's going to take on an integer a. It's going to take on an age, and then I'm going to do string set name. That's going to take on a string n for name. This is everything we did this morning. These are called. So these are, well, let's just make it here. Instead of putting it, I'm just going to put here data members. And then down here I'm going to put member functions. So I can easily turn this into a structure, believe it or not, by changing this keyword class to structure, and I've created a structure, but it's not going to work in object orientation like we're going to want it to work. So now we have this really cool .h file that doesn't really have very much going on with it. Instead, we just have our pseudo implementation. I can still compile it, which is not a bad idea to start compiling as we start writing it. So when I'm done with the .h file, which I'm done with, I'm going to compile it. So now what I'm going to do is show you, well, why didn't we put this all together? Because out in main, I can include the .h file and not have to include the .c++ object code. Makes it smaller. This is a lot smaller to look at than the full implementation of all of this. So out in main, in the main program out here, up on the top, if I want to make sure I don't forget this, because I'm going to use person, I'm going to use it inside of main, I can go #include, and then I'm going to use quotation marks because it's in the same directory and it's not a pre-compiled header, it's one of these user-defined ones. So I'm going to put in here, and it's case sensitive, person.h. So if I include person.h, then I can use it, but I don't have anything implemented for it, so nothing's really going to happen yet. So let's implement something, which means that we're now going to have to fill out the .c++ file. Let me know if I'm going too fast through this as well, but I'm basically setting up the stage here. Did I misspell something? String does not name a type. Yeah, there's a problem with string. I'm going to take the string out, actually. Let's just do it this way. Let's just see if that works. Let's just do it this way, actually. There's a funny thing with the capitalization. Let's just do it this way. Let's see real quick. String. Let's see if you're. No, I just changed the cases. String. Actually, all I have to do is click on one of those messages, and it should tell me. Let's just take a look here. String does not name a type. I believe that this has to be capital.
Actually, if you use the namespace string.
Ah, the namespace. That's the problem right there. Actually, no, that's not the problem. Let's take string out, and I'll troubleshoot this over between now and tomorrow. There's something funny. I always have this problem every time I try to use string with dev, and it's just a dev issue. Remember, we use string with Xcode, no problem at all. There's a really weird thing with dev and string.
It's called component that actually. You should use the namespace for string if you're using a string.
But I didn't, and it worked just fine for me. Complaints for you? I didn't see any complaints at all when I was using it. Let's take out string, and I will remember what that is. I just have to look at one of my other examples. I just don't want to waste time doing it right now. So instead, we'll just take out this one, and we'll make it 2 integers. Let's do weight. Just not have to worry about the string issue. So change the string to an integer, and now it's get weight now instead of name. And then this one's going to be an int w. Just so we don't have to deal with the string issue. And I'll figure that what that is for tomorrow's lecture, actually. I just don't want to waste time on it today. Unless I find an example in a few minutes. I might stumble upon it, or remember one or the other. So now it compiles just fine. It's because of that string. There's something really weird with it. I can't remember what it is. You don't have to use namespace in your classes. You don't have to put that in. The only where you have to put the using namespace is in the main.c++, because that's the only where you're going to use cin and cout and all the other things. These don't need namespaces. If you put namespaces inside of the class implementation, it messes it up when you try to go use it again. When you try to use this class in something else. Because essentially, in your C++ is where you're going to be writing the source code that's going to implement the methods that are associated with the .h file for the person. So you don't have anything in here that's going to need anything or associated with namespaces, long story short. So your person now has an integer, a get age, a get weight, age and weight. And so now what I'm going to do then is implement the, just implement something. So if we're going to implement something, what we're going to do is take one of these methods over here that we've got. We don't have to do anything with the data. That's already defined for us. So let's just take one of these like this one here and say, well, what's it going to be? We're going to implement get. Here, I'm going to cut and paste these actually so I don't have to type them again, or copy them I should say. So I'm copying them. I copied these two method prototypes because I want to implement them. We know how to implement methods, or functions. Pasting them in here. I'm going to have to do a couple of things that are a little bit different. What I'm going to need to do at the top is include person.h in the C++ implementation, so I know what I'm looking at. So I go person.h. I might have to use a namespace if I'm going to implement using, in fact, what we can do is kind of sort of see what the finished product is going to look like by opening up, as an example, what was the lower one, vehicle.c++. Let's see, vehicle.h, vehicle.c++. Here's an example where we're actually, I'm going to cut and paste it. I'm going to put it in because I'm going to be using it, so I'm going to cut and paste from here. What I did is I just double clicked on vehicle.c++ so I don't have to type things. It's already on my desktop, and it kind of gives me a little template that I can kind of use in terms of person.c++. So I'm going to put in at the top include person.h. This is in the person.c++ file. I'm going to paste in. Don't need this in the .h. We'll need it in the .c++ because I'm going to be using IOStream, or I'm going to be using for seeing out and stuff like that, which means I'm going to need it in the implementation but not in the prototypes, which is why I didn't put it in there. Then you can sort of see this funky little format. Well, all we do is we stick this here. This one's a vehicle.c++ implementation. So we say it's in vehicle : and then the name of this method in this particular case was called initialize. Well, let's go back to our person.h file. We're going to use the same syntax. So you always start out, because we're going to write a method. What's a method? Method's a function. We've been writing them all morning. We're just going to write another function. But we start out with the data type. This is what it would normally look like, but we're going to implement one that's inside something else. Actually, it would not normally look like that because we'd have the opening and the closing brackets. It would look like that. This was the function prototype I copied over. So I'm starting out with this as kind of like these are my implementations, but I need to know that I'm actually implementing it. So in front of get weight, I'm going to add person : So I'm going to say person and then 2 colons. The 2 colons is used as a scope resolution operator. It says inside a person, I've got get weight. And get weight I'm going to implement. So I'm going to do the same thing down here. I'm going to go person : get age. Which is essentially going to be my implementation for get weight, get age. In fact, I can probably do the same thing over here too on the sets. So I'm going to copy this over here and go back to the person.c++ file and put it down below, actually. Paste. And do the same thing, add the opening and the closing brackets. And this is the way that you can write your source code. This is one way that you can write it. It just happens to be kind of a methodology that can be used to, as a, kind of a design way of approaching the problem. Rather than sitting there staring at a blank page, you know, I always put the empty ones in here first, and then I'll go like this, and I'll go person, and I'm going to have set age, because there's no problem leaving it empty. So if you build the empty implementations, so now I've got person, set weight, person, set age, get weight. So now I'm going to take and compile it and see where I've gone wrong, and I go, oh no, it's working. So at this point, the one thing I haven't tested yet, I haven't done anything yet, mind you, I haven't implemented anything. I'm just kind of setting up the pattern that I'm going to use when I do implement this. Eventually I'm going to fill this out, but I don't necessarily have to fill it out right now. I can see if it works. I'm just not going to have anything done. So I'm going to go to main, and I've put person dot. I don't think I need this one up here, because I don't use this. I use get character instead. So I'm going to change this to my likings, because I don't like all this other stuff. I'm going to get rid of this guy up here. There we go. So I got IOStream and I got person. And I'm going to put a get character in here because I like that one better. And I'm going to make sure that this still compiles, and lo and behold it does. But when I run it, nothing's going to happen. It's going to show me this blank screen. So let's say get character. Okay, got character. So now what I'm going to do is the same thing I did with the person A and person B in that first example I showed you this morning. I'm going to create an instance of this object. So I'm going to use it as a data type. So I'm going to go person, because it's called a person, just like string is being used for a string. And person space P, I'm going to call it P1. And I'm going to put a semicolon on the end of it. So I got person P1. It doesn't really do anything, does it? Well, so let's do something. We can, let's set the, let's add a value to the X, because we have a public. So let's go back over here. Remember I put X over here. I can set X to something. So I can go person, let me show you what I did here. Out in main, I created an instance. So now I can go, as an example, this is what we did this morning. P1.x is equal to 10. And then I can go, well, let's just see out. And same thing we did this morning. X equals, and I can go, well, let's just print out P1.x. End line. There we go. So I'm playing around with this public data member that I did, and it was called X, if you remember. I put this one over here. This is a special case. This one here is a public variable, which is a bad idea. Because remember I said you're supposed to make, over here, data member. You're supposed to make the data members private. But let me show you what happens when we use a private one. We're going to get an error. So actually I'm going to close the vehicle for a second here so it doesn't get in my way. So I'm going to go back to main, and I'm going to say, well, let's see what happens. What am I going to do? I'm going to run it. I'm going to say x is equal to 10 is what shows up on my screen here. And this is the functionality you want to see out of this. This is working because x is public. If I change this here and I go age, P1 age, let's just change it and go age. So I've changed the X now and I've made it A, age, because I put X under here and I said this was a bad idea because it allows us to touch the data members without using the setters and the getters. So we create these setters and getters so we can change the values of the data in a more protected way. So we can't set the age to 0 or to a negative number. We can put the rules in when we create. This is why I kind of waited a little bit before I implemented it, because I want to put rules in there to say how tall can they be, how old can they be, stuff like that. What can we set it to? But we're supposed to get an error message because this one's now private. So we have the private age, which means we're not going to be able to touch that out in main. So if we go out into main, and now I set it to age, I'm expecting an error message of some sort. And here it is. And it says that in person, age is private. And I want to go, wow, that's not fun. That's not good. Let's go back over to person. And then we fix it, right? This is the wrong way of fixing it, by the way. We fix it and we do this. Okay, now it should work. It will, actually. Work just fine. So now I have, but I didn't change it. It says that age, it says X is going to be 10 again, but it's really age that we set and not X. They're both integers. That's the wrong way of doing it. So here's how we want to do it. We want to make this private. Leave it private. Don't change it. If you don't put public or private in there, leave this out. Let's see what happens if we leave it out. If we leave it out, ooh, whoa. It's supposed to make it private. Now let's put it back in because we want to make it private. It's supposed to by default make it private. In that case it made it public. So, but we want to use these methods, so let's run the method. So if we go back out to main here and we want to set the age, so we run it like this and we go set age, and we're going to set the age to 10. So this is what's called a method call. Well, it doesn't look like a function call. This part of it here is a function that we've been working with all morning. We're using the dot notation because this function is inside of the class that we just implemented. So instead of it being inside of the current main program or, accessible by the main program, we use this dot notation to connect this instance of the object called P1. We're going to run set age 10 from P1. Well, in order to do something with this, we have to implement the set age function. So we go back up to the implementation file, and lo and behold, we have a set age here. Well, what's set age going to do? It's going to take age and have it equal to A. A is coming in from the parameter line, and age is the variable that we defined in here. So the classic mistake some people do is they redefine age. We have age defined in the .h file, which is the specification. So the reason why it's called we specified that we're using age to hold the age, and we specified that we're going to use weight to another data member for weight that we're going to store for this person. So over in the implementation file, the .c++, we can just do this and we can go age is equal to A. And oops, that's the set. Yeah, we need to make it void. Should be void. The sets should be void. Why did I make them integers? I don't know. Void. If I make them void here, they have to match out in the .h file too. So I need to go out here and go use the sets here, make them void. So they match. Actually you could have left them on integer and you just have to return 0. What's it going to do? Nothing. It's just like main returning 0. Doesn't really do anything. But so now here we've got age up here is implemented here, having it equal to A, which we're taking in. So we're passing A from the main program out here. And A in this particular case, I'm going to change A to 21 so it looks like an age correctly instead of being 10. So we're passing it here by this method call that we're running here. So we can do this and we can go person P2, or I could put them both on the same line, person P1 comma P2. And then I can do the same thing here. I can go P2, P2, set age, and let's make him 50. We got an old guy and a young guy, or girl, whatever. So over here we're still going to have a problem because age is private. We can't print it out either. So now if I run it, I'm still going to get an error message because age here is private and I'm trying to see it out over here. In main, I'm trying to see it out, and it's not going to work. So if I want to do that, I'm going to get age. So get age is going to be the method call that I'm going to put in here that's going to return the age. If I return the age, then I have to implement the method to return an integer, return age. So if I go back over to the .h file, and I can make sure that get age, here it is, get age is an int, it's going to return an age. So I'm going to click on the C++ file, and up here where it says get age, I'm going to return age. So the line of code only has one, really seriously, it only has one implementation to it. And this is really could have been done as an inline function. I'm going to show you that later, but not to confuse you. The get weight is going to return the weight. Return the weight. Is weight capital or is it lower? Let's take a look here. It's lowercase weight. So get weight returns the weight. Get age returns the age. Set has age is equal to a, oh, I didn't do this one, so let's take weight and have that one equal to W, because that's what we have here. It's void, so it doesn't return anything. So now when we run it, I'll get rid of this bottom screen here. I still didn't change, did I change it on here? Yeah, get age. This is what P1 age. P1 age is 21. So, because I'm getting the age and then I'm setting the age. So we use the setters and the getters to manipulate the private data members because we don't want to manipulate those private data members. So if I come back here to kind of fix this, I'm going to take out this one here. Actually, I'll just comment it out because you might want to play around with it. Or actually, I can just leave it in there because we can have both actually. We can come out here and say, we can say that p1.x is equal to 99, and then we can use it down here. Actually, here, I'll put it on top. We can still use it. Sometimes it does come in handy for certain things. Why we want to use it, I don't know. It's totally up to you. P1, and then we're just going to print out X. So here we're printing out the data value, and in this particular case, I'm going to say X is equal to something. P1X. P1X equals something. So here, X is going to be 99, so I can print it out here. So I got 99, and then I got 21. One's public, one's private. In theory, you want to keep the data private because it protects it a little bit. So this is an interesting example. We've got this object out here, and we've put the functionality to create the instances of the objects out into main, and we're just running methods and doing stuff. This is exactly what the car program is doing. So this is one object. We can create another object, actually. So we got a person. Let's create a dog or a cat. So I'm going to create another object and show you it's done the same way. So I'm just going to kind of fly through this here. Create a source code file, add it to the project. Just to show you one more time, I'm going to rename this one. This one's going to be called dog.h. And in my dog.h file, I'm going to go class dog. I'm going to have opening and a closing. Then I'm going to say, okay, that was fun. Now let's implement it. You can put some spaces down here, and then if I'm going to follow through this kind of design template for you a little bit here, I'm going to put a semicolon at the end, make sure I'm doing it properly. And I'm going to say, okay, now I need an implementation file for this, so I'm going to create dog.c++. So I'm going to come in here, I'm going to go File, New Source Code. Okay, add another one, and let's call this one dog.c++. Now I got dog.c++ and dog.h. And in the dog.c++ file, is going to include all this stuff, so I can't do anything with that. I have to actually start in here first and, you know, maybe give Fido an age and Fido a name or something. So in .h, I'm going to define some private data members. And we're basically doing the same thing as we did before, but here I'm just going to go integer age. And then I'm going to discover, well, maybe we want some public member functions, and this one's going to be get age. Let's see, get age is going to return the age, so it's going to be integer get age. And I put a little function prototype in there. So there's some textbooks that put the data on the top like this. There's some that put it underneath on the bottom. It doesn't really matter what order. You can have public, private, you can have everything into one category. You can do it all like this, but you can't run the methods if you do it all like that. So, because everything has to be public. So, if you're going to do it that way, you do it this way. If you're going to do that, or you do it, you take this out completely, and by default the methods are public and the data is supposed to be private. So if I'm going to do it properly, I'm going to do it this way, and then go here, public. I don't get the same formatting as I do with, let me just put a space in here. And then I can test and I can go, yeah, it still compiles. And then I can go, well, what if I make a dog? So then I'm going to include the dog. So I'm going to go out here in main and I'm going to say, well, let's just include the dog. So include dog.h. Dog.h works just fine, and it should work just fine. And then out here I can say, what about dog D1 and D2? And then I can compile it and say, well, dog D1 and D2 works out just fine. And then I can pretty much continue with the kind of same process, and I can create another class, and I can create another class. So in object orientation, what we're doing is we're creating a bunch of classes, and we're using those classes inside of main, and we're making the classes as functional as possible so that they can store data, manipulate data, run data. So if I go back to dog.h, and I notice I have an empty dog.c++ file, I can actually leave it out of the program completely. What do I need an empty file for? Don't need it. So there's some people that when learning C++, they fall into this trap of what's called inline functions. So inline function declarations removes the prototype from the specification and just puts it in there. Well, let's do this one. I'm going to do dog inline so you can see what I'm talking about. If I'm going to do dog inline, then I'm going to need to probably, well, I'm going to need to do this. I'm going to need to take the iostream.h stuff that I'm going to need, because remember I haven't included anything here, so I'm going to go back up to dog.h. I'm going to put this on the top, because in here I'm going to take out this semicolon. This is what's called an inline function. So I've taken out the semicolon, I'm putting in opening and closing brackets now. And inside here, integer set age. Well, don't I need to give set age an age? So I'm going to go integer age here. And then here I'll write it like a real function, and then I'll show you why they call it inline in a few minutes here. So this one's going to be age is going to be equal to A. So I have opening and closing brackets, and I've created a function, and it works. And it's not inside of dog.c++, it's inside of dog.h. Here's why they call it inline. If the entire function can be written on one line, it's inline. And you can put it in the .h, no problem. If it takes up multiple lines, it doesn't belong in the .h. So a lot of people will put the setters and the getters inside of the .h and do them inline. But if I did that with person, there wouldn't be anything inside of .c++. And there isn't anything inside of .h. So I want to show you how this comes in handy, actually, and how this really looks. So I'm going to create dog with partly inline, partly implemented. So we have dog, he's got an age. Let's give him a weight as well. He's just like a person. But let's give him a bark. We're gonna have a method for him called bark. So this one's gonna be void bark. And I'm gonna make this one into a function prototype because I'm gonna implement it inside of my .c++ file. But this one here, I'm gonna do another inline. I'm gonna go integer set weight. And this is also going to take an integer w. Same implementation as we did, and I'm purposely doing the same implementation as we did on the person so you can sort of just see it one more time. Opening bracket weight is going to be equal to w. Oops, I need to put a semicolon at the end of that line. Did that actually work? Or did I get compilation errors? I need to put a semicolon at the end of each line. So. Which is interesting. No, it works. Interesting. Maybe I didn't compile it after I did that with it. Who knows? So then I can do another couple more of them. I can get real lazy and cut and paste them out of the other one. In fact, maybe I'll do that. I'll go over to person. I won't get lazy. I'll just write them. What are we going to have here? Void return. So we're going to get age. And then I'm going to have a void get weight. No, actually it's not going to be void. The set's going to be void. Let's just do this one here. This is void. Void set age and void. I did the same thing I did a few minutes ago. I don't know where my brain is today. Integer get age is still on veggie burgers from lunch. Let's see. What I got? Void set. Not returning anything. Void set weight, not returning anything. It's just saying weight is going to equal to w. Now we got get age. Well, that's going to return something. It's going to return age. Put a little semicolon in there. And then now we have get weight, and I've tried to misspelled actually. W-E-I-G-H-T. G-H-T. Yeah, my brain is on lunch. G-H-T, there we go. Return weight. And then we have void bark. And bark we're going to put into the other file. Does this actually run? It should run. There we go. Okay, good. We're in good shape so far. All right, so then I'm going to implement these three over here, and then I'm going to stick bark, and I'm going to stick bark over into the .c++ file. So over here in the .c++ file, I'm going to include, if I spell it correctly, the dog.h. And then I'm going to say, which one was this one? It's called void bark. So I'm going to say void dog scope resolution bark bark. And now I'm going to implement this guy over here. Well, what's the bark going to do? The bark's going to go yipe, 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 so see out. I know, it's kind of stupid. Yipe, yipe. What does dogs do? Yipe, 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 yipe. Or they go rough, 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 rough. You get the point, I hope. So I got one method over here. If you're going to do a .c++ file, you're going to have probably one method in there. Otherwise, why do a .c++ file? It works both ways. So usually you're going to have a .c++ file. It's going to be the implementation of your methods. There's no harm, however, in doing them in line like this. If you're just going to return something or set something, commonly see them done in line, actually. So now if I compile, I've got a problem here. I've got a problem because, oops, what happened to my thing? I got rid of the console window on the bottom. Void member declaration and dog. Do I not have a void? Dog bark. What was it not called bark? Oh, it's a capital and I used a lower. So I have to come back over here and make this one a lowercase bark. And then now I should be able to compile it. And I've got another syntax error here with the, what do I got going on here? It says a C out, because I need to put the namespace in here. So I have to go back over and copy the namespace from here and stick it over into the .h file for the, excuse me, the .c++ file for the dog here. Let's put the namespace in here. I may also have to include iostream.h, but we'll see. I do. C out undeclared, first use in the function. So let's make this proper. I was going to get the C. I was going to get the namespace issue next, but iostream. If I have spelled that correctly, we'll see that in a few minutes. And I spelled it correctly. So then I've got iostream because I'm using C out. And so there's some people that would do this, which is the same thing we're doing actually with the .h and the .c++ file. That actually works. If you do that, you don't have to do that. Which is kind of the same thing as doing this. So do you need to do this? Safer. Do you need to do this? Nah, too redundant. Why bother? So it's kind of funny that it's like some people will do it this way and then some people will do it that way. I see people doing it with the string class all the time. String, colon, iostream, colon, and then running the methods that way. So here we have the finished bark. So we can still run bark on a method. So we can do everything now. So we're going to go back to main and limited functionality. We'll build some more things onto this tomorrow, and then we'll make dog a certain type of dog. We'll inherit some other dogs from it tomorrow. So we'll build on the concept. But now we can go here. We can go D1, and we still haven't seen constructors yet either. D1.bark. So let's add a D1 bark in here. And so we can go like this and compile it and run it. Now we got yipe, rough. I don't know how you spell rough, but I don't know. You know, it's R-U-F-F. Wait a minute. Let me spell this correctly. Rough. There we go. Yipe, rough. Those people who have dogs don't hate me. I don't have any animals. I don't know what dogs sound like. Rough. So let's see. Yipe, rough. So you might notice that this is a little, I don't have any, I've made 2 dogs, but I don't have anything set for the dog. Because now I got to go through and I got to set the dog weight, I got to set the dog age, and then I got to assign some, you know, it gets a little tedious, doesn't it? What if I just want to make a dog and have some default values set for the dog? Then I use this thing called a constructor. I'm going to show you the default constructor right now because it's going to make my life easier, because then I can print some stuff without having to set everything manually. And I can do this with the person, and I can do this with everybody else. So the constructor, let me go back up to the dog.h file here. The constructor is nothing more than another, it's a special member function called a constructor. In C++ we have 3. In Java we only have 1, we have constructors. C++ we have constructors, copy constructors, and deconstructors, or some people call them destructors. I call them deconstructors. Constructors are constructors. They work the same. In Objective-C, they're called initializers. So they work the same in all languages. All they're going to do is set some initial values. So let's set some initial values for our dog. And I'm going to write what's called a default constructor because it's not going to take on any parameters. A copy constructor and a deconstructor are only used when dynamic memory is used. So if your object is going to allocate memory using pointers, and you're going to copy one object to another object, you're going to need a copy constructor. If you're going to remove the object from memory, we haven't looked at creating objects dynamically yet, and we'll do that tomorrow, but then you'll have to delete all of the allocated memory inside of that object, and you can only do that in a destructor. So because we don't have, as I was mentioning earlier today, it's statically allocated. Nothing's done dynamically, and no garbage collector for us. So we have to do it all of ourselves, which is what the destructor is all about. Languages like Java automatically make copies, and they automatically destroy the memory for you. So C++ does not give you that luxury for some reason. So, well, it's an older language. So a constructor has the same name as the class and does not have a return type. So we have something that looks like this, dog. That is the constructor. It looks like there should be a problem with that, because that's the first thing they teach you in programming courses. You can't have a method with the same name that matches something else. This method matches the class name. Well, that's how we know it's a constructor. So we put dog over here, and then we do the same thing in the C++. We can do this in line if we want to, but let's not. Let's put it in the C++ file. You might also notice a thing I do of habit. So I always put the data on the top. I'll always put all the constructors next. Then I put the setters and the getters. And then I put the methods underneath it. It's just a way of organizing it. There's no law that says you have to do it that way. You can have as many constructors as you want. This one here I'm going to call the default constructor. Default constructor, because it does not take on any parameters. We're going to have a dog that takes on an age, integer age, and it looks like just any other constructor. So this is a constructor that takes an age. We can do a dog that takes a weight. Constructor that takes a weight. Then we have a dog that takes an age and a weight. And the interesting thing is, let's see, constructor that takes both age and weight. So the interesting thing is I've got two that look like they're the same constructors. They both take on two integers, but I named the parameters different. If you do this, you're going to have a problem. That's a redefinition. One of them is going to overwrite the other one. If you change the variables, it's different. It's not the identical prototype, which is why you're naming them. Some people, and you can do this, you just put integer in here, then you can't name it. Then you might have some issues going on with that. So compile, it works just fine. Let's just implement one of them. I'm going to implement the default constructor because I want to show you what happens when we do this. So in dog, C++, I'm going to come over here, and I don't have a data type, but I still have to say it's in dog. So I go dog, : dog. And it looks kind of wrong, but it's really right. But it looks like it should be wrong. And let me just make sure I did put my semicolons at the end and I have everything lined up. I'm going to make this available to people, so I'm just going to make sure I have my comments in there too. It's a great way of writing examples while teaching at the same time simultaneously. Alright, so what am I going to do here? I'm going to set some default values for the dog. So I have an age and I have a weight. So over here I'm going to say age is going to be equal to 21. All of our dogs are 21. And the weight is going to be equal to everybody's 20. Now the people are either 50 or they're 21, one or the other. So what happened to the years in between? I don't know. Weight, well, how heavy? Our dog should be like 50 pounds. So we got a dog who's 21 years old and he's also weighs 50 pounds. So now we don't have to do anything when we create a dog. So when we create a dog out here, whoops, where's main? There we go, main. We can create a dog. So let me show you something though. When you do this, you've created references to objects. You've allocated the object, but you've created a reference. So the reason why we made that constructor was because we wanted to allocate automatically, but we haven't allocated. We don't allocate till we do the assignments. So let me show you a side effect of what's going on here, then I'll show you another thing, another way of doing it. So remember I said it's going to automatically set, the constructor should theoretically automatically be setting our age to 21 if we're a dog. So in main, I'm going to print out the age. So I've created a dog here, D1, and we'll just leave that in there alone. And we'll just go here, cout. And what we're going to see out, d1 dot age, get age, because we have that implemented. Inline. And then I'm going to put a little thing up here so we know this is it. See, d1 age, d1 age is. Oh, what do we got going on here? Integer, the dog int cannot be overloaded. Dog int. Let's not do that right now. There's another way we have to do that. Let's just do it this way. Let's see. Dawn. I think I meant to say dog, didn't I? Dog. Dawn. Okay, get rid of my typos here. Okay. So now let's run it and we'll say, well, we did set it. Okay, good. So now we have the D1 age is 21. We did allocate it. All right, so in some cases the reference doesn't do the general allocation. The default constructor is going to run in this particular case when we create the reference. There's another way, and let me show you another way in a few minutes here of creating an object. Let's go back into main. I see some typos I want to correct actually. I'll put a little space in here. There we go. I want to put 2 end lines in here so I can kind of differentiate what's going on here. So we ran the D1 and the D2, and we ran the bark, and we got the age automatically set for us. We can also create an object this way and go dog D3 is equal to new dog. Let's see. My syntax is going to be invalid conversion from dog to int because I don't have a dog. No, that's not going to do it either. Dog. Let's run it this way. 30. Dog, int, invalid. Let's save this for a second. I have to do something else before I do that. Let me hold that thought, actually, because I want to come up with a better, more planned example for you. Long story short, if you run the default constructor, it runs when you make a reference, it runs when you allocate the memory. When you want to actually allocate a dog with an age and a weight, you can also run it, but you pass it the age and the weight when you make the instance of the object, instead of just making the object like this and then going dog set weight, set age, stuff like that. Instead, what we can do is actually have the constructor do it for us automatically and pass the information. So it's like running a method, but you're doing it at the object instantiation, and the method you're running is the constructor that's running automatically when the instance of the object is created. So here, and in fact I don't want to move too far ahead with this because then we have to talk about the constructor order and what's going on with the constructors. And I didn't implement any of the other constructors yet. And I don't want to overwhelm you on the first day of class because this still is, believe it or not, is the first day of this class. So long story short, we have person P1, person P2, dog1, dog2. So we've made instances of these objects. We're using multiple objects in the same program, actually, together. We're not using inheritance yet. This is a flat first line field of instances of objects. So I keep using the word instance, and I haven't discussed that yet. So this is what's called the class. It's the template for the object. The object is created by the implementation of the .c++ file that goes along with the .h file. In main, when we make instances, we're making variables, references, if you want to call it that are instances. Actually, I didn't use new with that other example. That's why it didn't work. Where we have person P1, person P2, just like if we did this and said integer I, it's the same concept. We're making a reference to the particular object and the type that we're using as person, but when we create an object, when we create a variable that's from a class implementation, it turns into an object for us automatically. Which is kind of weird because if we go back to that structure, and we can put a structure in here, and we can make an instance of a structure as well. In fact, if we want to, we can define a structure up here on the top of the code, and then use the structure in here as well. We can use C and C++ together all in one program is what I'm trying to say. I'm not going to put a structure in here right now, though. When we start using new, we have to use a pointer, which is the mistake I was making before. So in here, if I said new asterisk p1 as a pointer variable and go equals new person, what I've done in this particular case is allocated it with a new person, which is a dynamic allocation versus a static allocation. So let me talk about that briefly, because I know this is going to be way over the top because I haven't talked about pointers yet. For people who aren't familiar with pointers, this is going to be way too much information overload. However, this is a good example here because we got one that's using a pointer and one that's not using a pointer. And yeah, I can't use it. I have to follow. If I'm going to do it this way, I'll just do it this way actually. P1's a pointer, so we have to use different syntax with it. Okay. I just want to make sure I'm showing you the correct syntax so I'm not leading you astray. This sucker gets created after we start the program, which is means dynamic. So we have essentially, let me make this screen a little bit bigger here. We have two instances that are created of the same object type. They're both people. We have a P1 and P2. P1 isn't created when I go up here and I press execute compile. It's not allocated, it's not created, it's not pre-configured. It's not even type checked actually. Hardly very much about it is used at all. We use this asterisk to say it's a pointer. I'm going to have an entire pointer lecture for you. Probably not till the second class weekend. So don't worry about pointers right now. But we need pointers with objects to conserve memory. Because if we do this all the time, we can't remove them. When we statically allocate, when you say integer I, integer x, this structure, that structure, it stays for the life of the program. It never gets garbage collected, never gets removed. And when we start creating objects, we're looking at bigger programs. We're looking at a lot of files, a lot of objects, and we want to be able to go new so we can turn around in another line of code and say delete. So we go delete P1. And what we've done is now we've removed it from memory so we can allocate it, deallocate it, allocate it, deallocate it, which is the only reason why we're doing it this way. For all intents and purposes, when we do this, the reason why this down here wasn't working because we have to use a different symbol. So we have the dot notation that's used with the regular object. So here we have P2. We're setting his age. P2 is a regular object. Well, I just deleted it, so let's not delete it yet. So we're setting their age using a dot. In order to set the age of a pointer variable, we have to use a different symbol. So we use a different, it's a different type of object because it's dynamically done instead of statically done. So in order to understand static versus dynamic allocation, however, you gotta like almost take a course in operating systems or maybe just in runtime programming language concepts might do it. But just think one of them is predetermined, happens pre-configured, pre-tested, predetermined before the program even runs. The other one doesn't have, nothing happens until the program actually runs. So iOS and Objective-C is 100% dynamic, which makes that a separate implementation of object orientation. Then C++, which is like 99.9% static by default, but we have dynamic features. So people add stuff to C++, like the use of the pointers and new, so that they can use it dynamically to make it run like languages like Objective-C. And then people wonder, well, why don't you just use Objective-C? It's a little easier. So for those people who got out of my Objective-C class a couple terms ago, and you went, oh my god, that's a hard language. It's hard compared to C++. I think it's much harder than C++ because the syntax is kind of foreign. It's more small talk than it is C. So C++ is an easier syntax, but it's harder to achieve the same objective because there's nothing about garbage collection in it. There's no dynamic anything. It's all static, and you have to makeshift it and pretend that it's working in an object-oriented fashion, and pretend that you have to do your own garbage collection, and you have to do your own memory management, and everything is done manually. C++ traditionally works on Windows operating systems. You know, it's Visual C++. It works great with .NET. Objective-C is the iOS and the OS. It's the OS X implementation of it. So used on iOS platforms. Because the memory module is different, it's on a Linux-based, BSD Unix, not Linux, Unix-based operating system. And it's slightly different breed. Both the languages are C-based, but they're like night and day between the two of them in terms of how they're implemented and how they're used. So in Windows, it's a stack-based runtime. So this comes from an operating system's perspective. So what do I mean by runtime? When you double-click on an icon in Windows, it takes the exe file, which is machine code, loads it up into what's called a runtime stack, which is a stack data structure. It takes data structures. You're not familiar with that. You've got machine instructor after machine instruction, and it populates out the process space for the memory and loads up a bunch of instructions, executes the instructions, you know, gives them CPU time, and it comes back and runs another instruction, and then it loads it back up, moves it back down, loads it back up, pops it back down. So it's like one of those little things that goes up, like an accordion, goes up and down, and that's how the program executes. In a non-static, non-stack-based allocated system, everything just goes out there, just loads it up all at one time, and you just reference back and forth. So there's no popping and pushing, there's no fill it up, take it out, fill it up, take it out. Slightly different, well, majorly different memory module for that. Memory management, majorly different implementation. So Objective-C as a language is more tuned for the dynamic. That's the dynamic, where you load everything up in memory and you just link to it and you run it and you don't pop it on, push it off. Versus the traditional Windows style, which is still even Windows 8 stack-based. So you load it all up, pop it all up. Nothing resides in memory. Then to confuse you even more, in C++, we can pretend to be dynamic. And I don't say pretend, actually, we are dynamic, using DLLs. So every Windows user is familiar with this concept called .dlls, because you get all these DLL errors and the registry keeps track of them. So in the Windows operating system, you create a dynamic environment using a static structure by dynamically linking. So you're almost doing a hybrid. You're loading up programs, which are the same programs you're writing as exe files, but they're loaded and saved and compiled as DLLs, which stands for Dynamically Linked Libraries. So you're not going to statically link them anymore. Instead, you're going to load them up into memory, and it's going to sit in memory, and you're going to dynamically link to it from a static program. So the program gets loaded up onto the stack, it goes out and finds, oh, where's that memory? So you got a memory address that's in the stack that goes, oh, it's over there. You go over there and you get it. You come back. So you don't have to keep loading it up, unloading it, loading it up, unloading it, because that's very inefficient. So there's pros and cons to both of the configurations. You're either going to make everything dynamic, or you're going to make it partly dynamic, partly static. What I'm trying to give you is a simple overview, and I'm simplifying something that's a little bit more complex than that. So it's more along the lines of what's the difference between dynamic and static. In fact, just go on the internet and Google it, actually, and you'll find half a dozen other explanations for it. What you need to know about is in C++, you got both. You got a statically bound language that you're making dynamic by using new and delete. You never use new, you've never done anything dynamically. You can use objects statically. Does it matter to you? One's going to be more efficient than the other. One program is going to run faster than the other. The static one's going to run like a snail, because you're going to pop it off, push it on, pop it off, push it on, pop it. Every time you're going to load the module for something, you're going to load the driver, you're going to load the class or something, it's going to have to be loaded fresh. And the worst thing you have to do is go over and find it, load it up, put it into memory, then take it out of memory, put it up into memory, take it out of memory. Can you just put it in memory and just leave it there? That's what you do here. You're using new, you're creating it dynamically, which means it's not going to be on the stack. Instead, it's going to be loaded once it's out there, which means if you go new, you have to go delete because it's out there until you delete it. And then when you're done with it, delete it, which is where that delete comes into place. So it's up to the programmer to delete
That sounds
things.
like a
So
static movement.
it's what?
That sounds like a static.
It sounds static, but it's dynamic because it's loaded after compile time and it's loaded at runtime. So it's really a cross between operating systems concepts and programming language concepts. Because so programming languages are application programs that are built to work on operating systems. So you have different application program development environments for different types of operating systems. Operating systems come in two different breeds, dynamic or static. So Windows is static. So we have a static C++ that has dynamic features to it because it doesn't work otherwise. And then we have a dynamic Objective-C that's cryptic and hard to work with, and then everything is supposed to be done for you. So because it's a little bit more complicated. And then we got Java, which works on everything. Because Java, actually, as language designers, they take a nice approach because they said, okay, we're not going to worry about static, we're not going to worry about dynamic, we're not going to worry about runtime, we're not going to worry about how any of this stuff's going to work. We just create our own. So they just create their own JVM. You'll load up the JVM. You write one program, it runs on everything. It runs on a Windows, runs on a Mac. So Java is a great language, actually. It runs on Android. It runs on everything. You only have to write the program once. C++, you got to write it millions of times. Objective-C, you can write it one time, but it only works on one operating system. Objective-C only works on the Mac. For those people who took my Objective-C course, you realize that in the first week when you say, you can't do this on a Windows machine? No, you can't. You have to do it on a Mac. Windows, you saw me earlier today with Xcode. I can program C++ on a Mac. I can do it on a Windows system. So that's one of the drawbacks of actually working with Objective-C, which is why it's not so popular of a language. C++ is more popular. So went off on a bit of a tangent, but it will save me time tomorrow because I won't have to explain as much static and dynamic, hopefully. But maybe after it sinks in overnight, it'll make more sense tomorrow. But long story short, we're going to do a lot of this tomorrow so we can see how that works. We don't have to do that. We can load things this way by running the instance with the parameters as well. But I have to actually implement the constructors in order to get that. So what do we got going down here? As I mentioned before, if we're going to use this syntax, we have to change these guys to pointer symbols instead. So if I changed it, it would actually run the same way. In fact, let me just do that now. Because everything that has P1 next to it has to change the symbol. Instead of using the dot, I have to use the arrow. And it's not really an arrow, it's a minus sign and a greater than sign. So it's two symbols used together that just says, hey, we're using a pointer and we're not going to use a statically allocated thing. So if we run it, for all intents and purposes, we have the same behavior. Works the same, runs the same, does the same thing. But we can do this if we want to at the end. We can delete. I'm going to put this at the end, actually. At the end of our code, we can do this. And I can get rid of P1. P1's no longer in memory. P2, you can't remove it. It's not removable, which means it's going to stay around for the life of the program. You create too many of them, you're going to run out of memory. So what do you need to do with that? Well, what if you have like a database you're implementing? You have a table that you loaded up. Don't you want to be able to unload the table when the user loads up another table? Because every time the user does something, it gets loaded up in the memory. And then that gets loaded up in the memory. Then that gets loaded up in the memory. You can't take anything out of memory. So then people learn, oh, we have to do it dynamically. If we do it statically, we can't remove it. The object's going to stay around forever. So you use this for memory management to make it more efficient. You're not worried about efficiency. You never have to touch a pointer in C++. So, unfortunately, well, Java doesn't have pointers. Objective-C has pointers, but it's like 50-50 pointers. You allocate, but you never have to deallocate. And you don't really use the pointers. It's just, I don't know why they just didn't pull them out completely. So, all right, so hopefully that wasn't information overload. I'm going to leave this alone. We're going to pick it up tomorrow as we continue. Do you guys want more for today? Well, you're shaking your head. I know we've lost half the crowd here. Because it's about 5:20. We can decent hour to go because we haven't had very many breaks. We've been going straight through. Or I can hold you for another half hour if you want. And we can go over, start a new topic. No. I want to make sure you get your money's worth out of this course. But you know what? We covered a lot today. So let me show you what you're going to do for assignment number 2 because we still have a few minutes here. So I'm going to close this project here. And between tonight and tomorrow, I'm going to figure out why the string's not working. It's a small little fix. I remember, you know, in the back of my head, I sort of remember it, but I can't think right now because it's too long of a day. So I'm going to leave that example, and instead I'm going to show you what we're going to do for assignment number 2. So I'm going to talk a little bit longer, and then we'll be done. How's that? At least I could feel like I went over assignment number 2, because this is what we're going to do tomorrow. We're going to build this, but I'm going to show you we've actually sort of built it already. Let's see. Unless my internet's not working, which... Well, maybe I have it downloaded. Here it is. Lucky for me, I have it downloaded. So one of the things, you never rely upon internet access. Alright, so this is what we're doing tomorrow. And this is assignment number 2, so if you're really bored tonight, you can actually do this assignment 2 and turn it in and be done with 2 assignments, 2 of the 5. Learn how to create and use a class in C++. So we did a person. This one's going to be an employee. So we're going to write a class definition for a class named employee. Isn't that like the person and the dog? And the class should include data members for the employee's name. So you're going to need to figure out how to do the string. I'll tell you the trick tomorrow. And salary. Salary will be an integer. It could be a double. It could be a float. I don't care what you use for that. The class should contain 2 member functions. The constructor, we just looked at the constructor. Tomorrow we're going to write more than just the default, and we're going to see how we can run multiple constructors for different types of instances and how the constructors work. And we're going to write a function here that allows the program to assign values to the data members. That's the setters and the getters. Set assigns values to data members, get retrieves them. Do them in both sets. I should probably change this wording where it says assign and get values to data members. But I probably should just put in quotes here, setters and getters. That's what I mean by that. Step number 2, you're going to add 2 member functions to the employee class. One member function should allow any program using an employee object to view the contents of the salary data member. No, it's the setters. Excuse me, that's the getters. So you're going to assign values, you're going to set them, and then this next part you're going to get them. The other member function should allow the program to view the contents of the employee name and the data members. Hence, have the member function simply return the contents of the appropriate data member. Number 3, you're going to, these are just steps, so you can do them all together. You're going to add another member function to the employee class. The member function should calculate the employee object's new salary based on the raise percentage provided in the program using the object. So you're going to give it a raise, and it's going to be a member function that's going to say, here, take this value that you're going to get, give me a raise. So you're going to raise the salary number, given some percent. Before calculating the raise, the member function should verify that the raise percentage is greater than or equal to 0. We don't want to give the guy a reduction when we're supposed to be giving him a raise. So you're going to put error checking. I'm going to talk about where to put that, but actually I already mentioned it earlier. You put it inside the method implementation. So the method before it will assign a new age or a new raise in this particular case. It's going to say, well, is this value more than 0? Otherwise, we're not giving them a raise. We're giving them a demotion. Not a deduction, just a bad salary. So you're going to put that check in the method so that when it sends it, it'll reply back perhaps, or print something to the screen or do something and say, hey, you can't give a guy a raise that's negative or something, So you're going to put the logic in there. And then step number 4, you're going to write the instructions to create an object, employee object. So the instructions to create the object, assign the values and the name and the current salary, etc. and so forth are missing. So you need to implement it in a main program. So come up with a complete program that uses the comments as a guide. This here Assignment number 2 is what I just wrote for you. Oh, it is bad here. It's just what I wrote for you. Started it today, actually. And we wrote a person. Isn't a person an employee? So you got to change it. Give them a salary and a name. So don't stress on the name. I'm going to show that to you tomorrow. It's going to be a string. I just have to find the right example for it. Long story short, by the time we end tomorrow, you'll have 2 and probably number 3 done too. Not a highly intense course. It's pretty easy. Although, if you're brand new to this, you're going to find this a little bit more challenging. So I'm assuming some of you may have some experience in other languages. So save up your questions tonight. So when you go home tonight, figure out, oh my God, I'm so overwhelmed. I have no idea what she's talking about when it comes to constructors. What is that all about? Save up your questions, and then we'll start out with questions tomorrow morning at 9 o'clock. We'll start out with questions about all of the things that you thought about overnight. And if you want to, you can probably assemble number 2, actually, if you're done with number 1. And then when you're all done, upload it to the EMS, and then you'll be way done with the course. So. Questions? Yes.
I have this question when you were explaining
Yeah.
constructor.
Uh-huh.
I'm wondering, does constructor, because for your example for dog, it was assigned to its weight and its what was it, height or
Yeah, the
something?
dog
Age.
default constructor set the weight to 50 and the age to 21.
So my question is that in general, constructor supposed to be assigned to specific type of variable?
Actually, if I were doing this, I'd probably do this like this. Integer this, 0, 0. What you want to do is assign initial values to the data members. Oh.
Integer and like character. I mean, does it supposed to point to one type of variable only?
No. Any type. Tomorrow we're gonna mix and match and put strings in here too, and set names and get names and stuff. It works. Constructors can set data for anything. Classes can hold data types of anything. I've been using integers to simplify things today. Open the door on that one. It can be floats, doubles, strings, other classes. One of the things we're gonna do tomorrow is put a class inside of a class. So it can hold everything. Don't think it's just limited to integers. Some students have an easier time understanding integers than anything else, so it's easier for concept-wise, but no, this could be anything.
Okay.
Yeah. Good question.
I sent you another email to
Okay.
if it's possible to send me this project activity.
It is. Do you want it tonight or do you want it tomorrow?
If you can do it as earlier as you can.
Okay, I'll do it tonight.
Because I couldn't both do the two things at the same time.
Oh, okay, so if I give it to you, and let me just make sure I didn't change anything good. I'll give it to you tonight, and then you can have it for tomorrow. I'll just do it right now, actually. And one thing I wanted to point out, actually, is for those people who have put this on their desktop, you'll notice a bunch of intermediate files that have been collected as I've been compiling, and they all have .os. These are the .os I've been talking about. So each one of the object files, here's a dog.o, here's a main.o, and I should have a person.o over here. These are the object files that get linked. So they have O for object. So the compiler goes, so unless you change it, never going to get linked. So out, you're never going to get recompiled. So out there in your program, if you look at the subdirectory for the dev program, I'm not going to do that, but if you look in your scene include, you see a bunch of .os. .o this, a .o that, .o, and it's iostring.o, string.o, stdio.o. It doesn't get recompiled, so when you do the .h, it links the .o. So it's the same concept, actually, for those. And you see them out here. You can go ahead and delete them. You don't need them. When you give your program out, you're looking for the .exe file, and here it is right here. It's called test C++, actually. So. All right, so I'll leave you with that. We're officially done for today. So I'll stop this video, too.